Hi guys. So this is second part of the congruence of the triangles. These are the concepts which we discussed in the previous video, right? So we are done with fundamentals, CPCT, congruence of criteria for congruence of triangles. We discussed SAS rule here, right? What is the meaning of SAS rule, right? We are done with this. So we are done with SAS rule. We are done with ASA rule. ASA rule. Now we are going to do what is AAS rule. Okay, let us see AAS rule. AAS rule. Let us see what it says. Okay, AAS rule. AAS rule says this is two triangles. Okay. Okay, these two triangles AAS, just name it A, B, C, and then I'll say P, Q, R. Okay, AAS. You take two angles, A corresponding to B, this is corresponding to this, right? And then S. AAS, angle, side. Angle, side. Okay. AAS means angle, side. Angle, side. So on the basis of this rule, you can say that triangle ABC is congruent to triangle PQR. Right. So after that, you will do this. Then match the corresponding vertices. You are pairing A is to P, B is to Q, C is to R. And accordingly, you will say that since the two triangles have been proved to be congruent, so you can use CPCT. Corresponding parts of congruent triangles are equal. Right. So for that, you can say angle C is equal to angle R, AB equal to PQ, AC equal to PR. Okay. So now we will talk about the fourth rule. Okay. We'll talk about the fourth rule. Let us see what it says. Fourth rule basically talk about SSS. SSS rule. Right? So it says that, just for that, what we do, SSS rule, though we have already discussed it here, but I'll discuss it again. So as for this is a triangle. Okay, sorry, this is triangle. I can make a triangle like this. Make it like this. Yeah, I can make it like this, and then I can enlarge it and make it like this. Okay. So this is equal to this. This side is equal to this side. This side is equal to this side. So this is, you can say it is P, Q, R, and this you can say triangle S, T, U. So since all the corresponding sides are equal, that is what we call SSS, side. Okay. So in this case, triangle P, Q, R is congruent to triangle STU. After that, what we will do? We will do match the corresponding vertices. That P is matching with S, Q is T, R is U. Okay? And then we will use CPCT. Sorry. Then we will use CPCT. Okay? To prove the congruence of other corresponding parts. For example, angle P will be equal to angle S, Q is equal to T, angle R is equal to angle U. Right? So as there are 9 elements of a triangle, so corresponding parts, right? Okay, here the fifth and the last one which we are going to talk about is that this is a right angle triangle. Okay, this is a right angle triangle. I'm going to draw this one again. Yeah. Okay. So this is, let's name it A, B, C, X, Y, Z. Right? RHS. This is called RHS rule. I forgot to write here. It is called RHS. RHS rule. Okay? RHS. Okay. I think I must write what is the full form of RHS. RHS. R means right angle. Okay? R means right angle. H means hypotenuse. Okay? Hypotenuse. Okay, hypotenuse. And S means side. So how it can be proved? Okay. It means what it means. It means if the angle B is 90 and angle Y is 90, okay, hypotenuse is the side which is opposite to the 90 degree. Side which is opposite to the 90 degree. So this is the hypotenuse. This is equal to this. And apart from that, any of the sides is correspondingly equal. So you can say this side is equal to this. Right? So you will say that triangle ABC, okay, is congruent to triangle XZY. Triangle XZY. After that, you will write down the mapping of three vertices. That A is, the corresponding vertex of A is X, C is B is Y. Okay, I did some mistake here. So it should be X, Y, Z. Sorry, I went this way, A, B, C. Okay. So it is X, and then it's Y, and then it is Z. Yeah. So as per this, what you learned that this I must write. A is corresponding to, see here, A is corresponding to X. Vertex A is corresponding to vertex X. Vertex B is corresponding to vertex Y. Vertex C is corresponding to, this is corresponding to this. C is corresponding to Z. So we are done with the matching the corresponding sides, and now we can say that since this triangle is congruent to this triangle, so you can say that this side is equal to this side, this angle is equal to this angle is equal to this angle, right? All other symmetry, as per symmetry, right? Okay, now we are here to discuss something about isosceles triangle. Okay, isosceles triangle, we will discuss that. So what happens in an isosceles triangle? Isosceles triangle. Isosceles triangle. Okay. So what we are doing that isosceles triangle. So okay, before I move forward, so we have discussed all the rules. Okay. So we are done with that. Okay. So now we jump on to isosceles triangles. What are the isosceles triangles? Isosceles triangle is a triangle in which two sides are equal. Isosceles triangle is a triangle in which two sides are equal. So that means, so suppose you have taken this. Alright. I'll go this. Wait. Isosceles triangles are triangle. Isosceles triangle is a triangle. Let us call it ABC. A, B, C. Okay. Isosceles triangle is a triangle in which two sides are equal. This is equal to this. This is one type of isosceles triangle, right? So when two sides are equal, the opposite angles are equal. Isosceles triangle can be this type also. Okay. You can say this is equal to this. So when this is equal to this, call it R, P, Q. Okay. So RQ is equal to PQ. Okay. So the corresponding sides are corresponding angles means opposite angles are equal. Opposite angles are equal. Right. Okay. So similarly it can happen. So or the converse is also true. The converse is also true. Converse means what the converse is? Converse is that if in a triangle two angles are equal, if in a triangle the two angles are equal, this angle equal to this angle, that means if it happens, that means this side is equal to this side. Right? This side is equal to this side. So this was the thing I wanted to discuss about isosceles triangle. And the last thing, equilateral triangle. Okay, equilateral triangle. Okay, what we know about that? Equilateral triangle is a triangle in which all the three sides are equal. All three sides are equal. Let us draw an equilateral triangle. This is an equilateral triangle. Okay, in which this. So we know the sum of the angle is equilateral triangle is any triangle. Sum of the angles in any triangle is 180 degree, right? So each of the angle in an equilateral triangle is 60 degree. All are equal, right? So it is 60 degree. It is 60 degree. It is also 60 degree. So this is the case of an equilateral triangle. So are we done with the agenda? I think it's yes. We are done with the agenda, right? So we discussed the fundamentals of congruence. Okay, we discussed the fundamentals of congruence. What we mean by congruence. Okay, we discussed that, and then we discussed about CPCT, corresponding parts of congruent triangles. How to use CPCT? The golden rules I have written here. Prove that the two triangles are congruent. First step. Step number 2, we will use matching the corresponding vertices, right? For example, here we match the corresponding vertices, right? Here we match the corresponding vertices after establishing that the two triangles are corresponding, congruent, okay? And then go and use CPCT. Corresponding parts of congruent triangles are equal. CPCT means corresponding parts of congruent triangles are equal, okay? Isosceles triangles, two sides are equal, so opposite angles are equal. This can also be the case. This can be the case. Or if two angles are equal, the sides are equal. Equilateral triangles are those triangles in which all the three sides are equal. The value of each of the angles of an equilateral triangle is 60 degree, that is fixed. So that was the theory part of the congruence chapter, okay, chapter 7. And I'll be discussing, I'll be trying to solve all the problems which is given as part of examples and as well as exercise. So there are 3 exercises in that, 7.1, 7.2, 7.3. So in my next video, I will solve those exercise questions along with examples questions. So thank you very much for watching. Have a good day.